Welcome to this Sahara 4 exercise. In this exercise, we will use the Volumetrics tool to do a quick calculation of the average net thickness of the different layers in the project. For that, we will go to our Sahara project, and once here, we will open the Tools menu and go to Volumetrics. Once here, the volumetric window will open, and here we can select in which map we will base the calculation on. In this case, it will be net thickness. Here we can select in which layers we will perform the calculation. We will select all of them. Here we can define how the calculation area is limited. In this case, we can either define a line as the limit of the calculation. For example, we can check to the calculation inside the borders of each different layer. These lines have been imported as layer lines in a previous exercise, or we can define a generic polygon as the limit of the calculation. Here we will define it for borders. And here finally we can define the calculation method. In this case we have the quadratic surface. In this case this method is going to fit a quadratic surface around each different calculation cell and integrate that surface. Or we can select without any interpolation. In this case this is going to directly use the value inside of each different cell or inside the grid of the map. So here we will do it with quadratic surface to have a better approximation and click on calculate. Here we can see that the calculation is being performed and we have the values, the final values in this table. So here for all the different layers that have data, net thickness data inside of them, they have a map defined. We can see that the calculation line has been borders, all of them have it available. And here we can see that the total volume is this amount is in thousands of barrels. We have the area, the total area. Consider that this total area here is going to have in consideration to include in the calculation all those values that are negative or that are null or zero. Here we have this average considering the total volume and the total area, and here we have effective area and effective average, which in both cases will not consider the values that are zero or those that are not valid inside the borderline that has been defined. So in this case we can have a better approximation here with this effective average that will show the average of the net thickness in each different layer. So the good thing about using this effective average is that if we have a map that only has the net thickness has only been defined for a specific area that might be not as big as the total border of the layer, we can have better approximation with this effective average. Here we can either copy the results or save them as a report. For now we will close this, and now let's check an example here. Let's use the net thickness map, and here we will also include the lines borders. So here we can see, for example, for the layer number 7, that there are plenty of different areas of the map inside the border that doesn't have any value of net thickness. So that's the difference between the effective area, the effective volume, and the effective average compared to the volume or the area that has been considered for the total shape of the borderline. Here what we can do as well is to create polygons. For example, let's open here the polygon window. This window will allow us to create polygons inside the map. We can create them with this button here. There is already a polygon exercise loaded in previously, but we can do a quick example here. So let's select this polygon, and here we can select all of them if we have more than one. We can delete it or edit the vertex of the polygon as well, like this. In this case we will save this polygon as a generic polygon, and we will call it generic polygon 1. In this case this generic polygon, as you can see, has been included for layer number 7, and we can use it as the input of the volumetric calculation as well. So we will go back now to volumetric. We will do the calculation only in the layer that has been selected, but we could do it in all the layers if we wanted. And here we will select the generic polygon. So now the net thickness calculation will only be performed inside the polygon that has been defined. And now we can see that in this case, as all the area that has been defined inside the polygon has values that are that are not null or they are not negative, the total average and the average, the area, the effective area, and the effective average will be the same. There won't be any difference between effective area and area or effective average and average, because all the values inside the polygon that has been defined for this layer are valid. We could, for example, consider the same polygon. Let's load it again. So to load a polygon, you can go here, load a generic polygon, and here we can load it, and we can see that here the same polygon that we defined for the layer 7, in which all the values were valid, here only a small amount of the total area inside the polygon has valid values inside of it. So now we will return here and do another calculation for layer number 7, and now we will include layer number 8, just for you to see that probably we will have a big difference now between the average and the effective average. So as you can see here, now there is a big difference in this layer, but layer number 7, as all the values inside the polygon are valid, we will have the same result between the average and the effective average. So that will be everything for this tutorial. You can as well, if you sum here the both effective average, you will have the same result as doing this, and doing the sum between the different layers inside the polygon that we define. So that will be everything for this tutorial. I hope it was useful, and have a great day. Thank you for watching.